Have you ever wondered why objects fall to the ground when dropped, or why we don't float off into space? These questions have puzzled humanity for centuries, leading to the discovery of a universal phenomenon, gravity. This invisible force is responsible for keeping our feet firmly planted on the ground and the Earth rotating around the sun. Whether it's an apple falling from a tree or the moon orbiting our planet, gravity plays a starring role. It's the unseen puppeteer, pulling the strings of the cosmos and dictating the dance of celestial bodies. From the smallest speck of dust to the largest galaxy, nothing escapes its grasp. It's an integral part of our daily lives, underpinning the most fundamental aspects of our existence. Yet it remains one of the most intriguing and least understood forces in the universe. This leads us to the question, what exactly is gravity? Gravity is a force that attracts any object with mass to another. Picture this. You're holding an apple and you let it go. What happens? It doesn't float in the air, it falls straight to the ground. This is gravity at work, pulling the apple towards the Earth. Now let's take a step back and think about why this happens. The answer lies in the object's mass. In our everyday experience, we often use the terms weight and mass interchangeably. But in the realm of physics, they're two different things. Mass is a measure of how much stuff an object contains, while weight is the force of gravity acting on that mass. So a more substantial object like the Earth has a greater gravitational pull than a smaller one, like an apple. This is why when you drop an apple, it falls to the ground rather than the ground rising up to meet the apple. The Earth's mass is so large that it exerts a strong gravitational force, pulling objects towards it. But it's not just about size. Distance also plays a crucial role. Think about when you jump. You're defying gravity, even if just for a moment. But you don't end up floating away into space. That's because the further away you are from the Earth, the weaker the gravitational force. So even at the peak of your jump, you're still close enough to be pulled back down. And it's not just objects on Earth that are affected. The moon orbits around the Earth because of gravity. The Earth orbits around the sun because of gravity. In fact, every celestial body in the universe is influenced by this force, constantly pulling them towards each other. So gravity is the force that keeps us grounded, but how does it work? To understand how gravity works, we need to delve a little into the realms of physics and look at two key theories. First up is Albert Einstein's general theory of relativity. This theory explains the relationship between mass and energy. It suggests that mass distorts spacetime, kind of like how a bowling ball would warp a trampoline. This warping creates what we call a gravity well that pulls other objects towards it. So, according to general relativity, gravity isn't a force in the traditional sense. Instead, it's a result of the way mass interacts with the fabric of spacetime itself. Now let's rewind a bit to the 17th century, where Sir Isaac Newton's universal law of gravitation comes into play. Newton gave us a practical mathematical model to explain gravity. He proposed that the gravitational force between two objects is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. In simpler terms, the bigger an object is, the more gravitational pull it has on another object. These two theories might seem different, but they are essentially two sides of the same coin. Newton's law provides a practical way to calculate gravitational forces, while Einstein's theory offers a deeper understanding of the phenomenon itself. What about mass, you ask? Well, gravity depends on an object's mass. Objects with larger masses have more gravitational force. That's why Earth, with its enormous mass, has a gravitational force strong enough to keep us grounded. Now let's circle back to the warping of space-time. The general theory of relativity explains how a massive object distorts space-time, pulling surrounding objects towards it. This warping determines the movement of objects, and it's this movement that we perceive as gravity. Gravity, therefore, is a result of the warping of space-time and the interaction between masses. These theories give us a comprehensive understanding of what gravity is, how it forms, and how it operates. It's a fascinating dance of cosmic forces shaping the universe as we know it. Now that we understand what gravity is and how it works, let's explore how it affects our lives. Gravity, this unseen force, is like a silent yet powerful conductor orchestrating our lives. One of its most obvious effects is keeping us grounded. Literally, without gravity, we would float off into space. It's the very force that keeps our feet firmly planted on the ground. But gravity's influence extends way beyond just keeping us from floating away. It plays an indispensable role in regulating Earth's climate. That's right, it's gravity that holds our atmosphere in place, creating a protective layer around our planet. This layer shields us from harmful solar radiation and helps moderate our climate, making life on Earth possible. Gravity also provides the right conditions for life as we know it. It governs the growth of plants, pulling water and nutrients from the soil up into their roots. In the animal kingdom, gravity has influenced the evolution of various species, shaping their physical traits and behaviors to cope with this constant force. But what about the water cycle, you ask? Yes, gravity is at play there too. It pulls the rain down from the clouds, replenishes our rivers and oceans, and maintains the balance of our ecosystems. However, like any powerful force, gravity has its downsides. In the realm of space travel, high gravitational forces pose significant challenges. Astronauts must train rigorously to withstand the intense gravitational pull during launch and re-entry. Back on Earth, gravity can make the operation of certain devices and machines difficult. It puts strain on structures and machinery, reducing their durability over time. And in sports and physical activities, the force of gravity can sometimes lead to injuries due to overloading. So there you have it. Gravity, a universal phenomenon, is integral to our lives. It's an unseen force with significant effects, both positive and negative.